Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos. So hello and good morning students. We'll be talking about Klein's construction today. Klein's construction is nothing but it's a technique using which you can calculate the velocity and acceleration of different links of a single slider crank chain. So let's see the Klein's construction in detail. So first of all, let's see what all things we have to study in this chapter. In this chapter, we have to calculate velocity and acceleration. Velocity and acceleration of what? Of single slider crank chain of a 4-bar chain. So there are two chains that we have in our syllabus, that is a 4-bar chain and a single slider crank chain. Now single slider crank chain, to calculate velocity and acceleration you have three methods, and in a 4-bar chain you have only one method. So let's first of all list down all the methods. First is the analytical method, that is using formulas. We'll be having a few formulas to calculate velocity, angular velocity, acceleration, angular acceleration, everything. So using the formulas you can easily calculate the velocity and everything. So it's a pretty simple method. Second is a Klein's construction. Klein was a scientist who studied about single slider crank chain, and he gave a technique using which you can calculate the velocity and acceleration of different links of single slider crank chain. Third is the graphical method. So in single slider crank chain you have three methods. In a 4-bar chain you have only one method, that is graphical method. So first we'll be starting with single slider crank chain, and in single slider crank chain we'll be doing Klein's construction, then we'll be doing analytical method, then we'll move on to graphical method, and finally we'll do 4-bar chain graphical method. So first is the Klein's construction, that is used to calculate the velocity acceleration of different links of a single slider crank chain. First, we've seen there are three ways in which you can calculate the velocity and acceleration in single slider crank chain: graphical method, analytical method, and Klein's construction. For 4-bar chain, there is only one method, that is graphical method. So first we'll be doing Klein's construction to calculate velocity and acceleration of a single slider crank chain. For Klein's construction, first of all you need to draw a single slider crank chain, and after you draw a single slider crank chain you have to follow certain rules, and after that the thing that you'll get is nothing but the velocity triangle and the quadrilateral of the acceleration. So first of all let's draw the single slider crank chain. We've already seen in chapter 1 how a single slider crank chain looks like. So first let's draw single slider crank chain. So as you can see here, the single slider crank chain is ready. O, A, B, OB, O, this bottom link, as you can see, it's a fixed link. This is the crank and this is the connecting rod and this is the slider. We have 4 links at total. O, B is the fixed link, OA is the crank, and this is the connecting rod and this is the slider. Now first we'll be doing certain construction here, and then we'll get a velocity triangle, and after few more constructions we'll get a acceleration triangle. So first of all, what you need to do is, to get the velocity triangle, you have to extend the connecting rod along the you have to extend the connecting rod in the reverse direction, back side, and also from point O you have to draw a perpendicular line to the horizontal. So after these two lines intersect, you get a velocity triangle. So what I've done is I've extended the connecting rod in the reverse direction. I've drawn a perpendicular line to the horizontal from point O. Now these two lines intersect at some point, and let's name that point as point C. Now you get a triangle OAC, and that triangle is nothing but the velocity triangle, and all the three sides of the triangle represent something. So I'll write it down what the three sides represents first. So triangle OAC represents velocity triangle. Now in this triangle, OC represents something, OA represents something, and AC represents something. So let's see what each of the side tells you. So the length OC tells you the velocity of the slider. So this is the slider. So you measure the length OC, and whatever value that you get is nothing but the velocity of the slider. Now this length OA represents the velocity of the crank. The crank is performing circular motion. The point A will be having some velocity which is perpendicular to the crank. So this length OA represents velocity of crank. Now the length AC represents velocity of connecting rod. So if the question comes in exam, write a short on Klein's construction. So you have to draw this, and you have to write what each of the three length represents: OC, OA, and AC. So you cannot make any mistake here. If you make a mistake here, you'll get wrong for this question. So remember these things, very important. OC represents velocity of slider, OA represents velocity of crank, and AC represents velocity of connecting rod. So you can directly measure these length, and you can get the value of the velocities. Now the velocity triangle was very simple. Next is the acceleration of different lengths. So for acceleration, what we need to do is, first of all, now we've seen the velocity triangle. Now let's move on to calculate the acceleration. For acceleration, you have to go to point A with A as center and AC as radius. You have to draw a circle. the circle has to be very light with A as center, AC as radius. You have to draw a circle, and the circle has to be very light because it's just a construction things that we are really interested in is the triangle, that the velocity triangle and the quadrilateral that we get, that is the acceleration quadrilateral, and rest of the things has to be very light. Now next thing that you have to do is you have to mark the center of the connecting rod, and from the center you have to again draw a circle taking the radius as half of the connecting rod. The length equal to half of the connecting rod is the radius, and the center of the connecting rod is the and the center point of the midpoint of the connecting rod is the center. So first of all, we need to mark the center of the connecting rod. So as you can see here, more than half draw arc, keep on the other side more than half draw arc, just join the two intersection points and then you'll get the midpoint of the connecting rod. So as you can see here, this is the midpoint of the connecting rod. It is a basic way to calculate the midpoint to calculate the midpoint of the connecting rod. The Klein's construction. So as I said, you have to draw a circle taking A as center and AC as radius. You have to draw a light circle. Next is one more circle you have to draw taking the center of the connecting rod as a center and the length equal to half of the connecting rod as radius. For that you have to first of all mark the center of the connecting rod. So I've marked the center of the connecting rod. This is a basic way in which you can calculate the midpoint. Take more than half, cut an arc both sides, keep on the other side, cut arcs, and just join the intersection of the arcs, and you'll get the midpoint. And after you get the midpoint, go to the midpoint, take it as center, and go to one end of the connecting rod, take it as radius, and again draw a circle, a very light circle. The whole circle is not required in this case. Now I've got one more circle here. क्यों? हाँ तो वो से वो लोग प्रोसीजर समझ रहा है ना. मेन ये जो ब्लैक वाला है वो दिख रहा है, वो ब्लैक वाला दिख रहा है. हाँ तो बस वही इम्पोर्टेंट है. Start. So I've drawn two circles. First circle is I've taken A as radius and A as center and AC as radius. I've drawn a circle. Next is I've taken the midpoint of the connecting rod, taking that as the center and the length equal to half of the connecting rod as radius. I've drawn another circle. Now what you have to do is you have to the two circles will intersect each other at 2 points. So this is the first point and this is the second point. So the two circles will intersect each other at 2 points. Just join these 2 points by a dotted line. So the two circles will intersect each other at 2 different points. I have joined the 2 points. Now this dotted line will intersect. Now this dotted line will intersect the connecting rod somewhere, and it will again intersect the horizontal link somewhere. So just do one thing. Just dark the part which is lying between the connecting rod and the horizontal line. So you will get two different points. The dotted line will somewhere intersect the connecting rod. Name that point as P, and the dotted line will again intersect the horizontal line somewhere. Name that point as Q. So you get a quadrilateral OAPQ. This is a very important quadrilateral, which is nothing but the acceleration diagram. So this different lengths of the quadrilateral will tell you different acceleration of different lengths. So the quadrilateral OAPQ represents acceleration diagram. Now OAPQ represents acceleration diagram. So each of the length, that is OA, AP, PQ and OQ, will tell you something about the acceleration of different lengths. So let's see what each of the length will tell you. So the length OA, as I've already told you that the radial acceleration is always along the length. So OA is the acceleration of the crank, and that too radial acceleration because it is along the link. So OA is radial acceleration of crank because radial acceleration is always along the link. So the link is OA, and the link is crank. So the length OA represents radial acceleration of crank. So the radial acceleration is always along the link, and the link that we are having OA is the crank. So OA represents radial acceleration of crank. Now, as you can see here, AP is the length which is along the connecting rod. As you can see, this is along the connecting rod AP, and the radial acceleration is always along the link. So AP represents the radial of connecting rod. So since it is along the connecting rod, it represents the radial of connecting rod. So it is very important, and there's also logic behind it. AP represents velocity, radial acceleration of connecting rod. And the next is PQ. As you can see, PQ is almost perpendicular to the connecting rod. So the component of acceleration which is perpendicular to the connecting rod is the tangential. We've seen what tangential acceleration is. Tangential acceleration is always perpendicular to the link. So PQ, as you can see, is perpendicular to the connecting rod. So it has to be the tangential acceleration of the connecting rod, because the tangential acceleration is always perpendicular to the link. So PQ represents tangential acceleration of connecting rod. Last is OQ. OQ, since it is horizontal, and the slider which is having a linear motion, horizontal motion, so it represents acceleration of slider. Slider will be having acceleration because it has to go to and fro, and a to and fro motion cannot be a constant velocity motion, because once it is going towards the one end, it has to stop, it has to again return back to the again the same position. So it cannot be a constant velocity motion, it has to be acceleration motion because it has to gain velocity, it has to become zero, again gain velocity. so it cannot be a constant velocity motion. So the slider performs accelerating motion, and the acceleration of slider is given by the length OQ. Since it is horizontal, and the acceleration of a slider will be horizontal, OQ represents acceleration of slider. So if a question comes on Klein's construction, this is all you have to do. You have to first of all make a single slider crank chain. Then for the velocity triangle, you have to just extend the connecting rod in the reverse direction, draw a perpendicular line from point O perpendicular to the horizontal, get a triangle, and each of the three sides represents something. I've already told you that. For drawing acceleration diagram, you have to draw two circles. First circle taking A as center and AC as radius, you have to draw. Next circle will be the center of the circle will be the midpoint of the connecting rod, and the radius will be half of the length of the connecting rod. You have drawn the two circles. Now, after you've drawn the two circles will intersect each other at two different points. Just join the 2 points by dotted line, and that dotted line will intersect the connecting rod somewhere. Name that point as P. That dotted line will intersect the horizontal line somewhere. Name that point as Q. And the part of the dotted line between the connecting rod and the horizontal has to be made dark. That is the PQ part. So O, you get a quadrilateral OAPQ, that is the acceleration quadrilateral. So that is acceleration quadrilateral, and different lengths will tell you different things. OA is radial of crank. AP is radial of connecting rod. Since OA is along the crank and the radius is always along the link, so OA tells you the radial of the crank. Then AP tells you the radial of the connecting rod. PQ tells you the tangential of the connecting rod, and OQ tells you the acceleration of slider. So you have to draw this diagram, then you have to write these things. You have to write what each line represents. So that was all about this topic, Klein's construction. It's a pretty simple topic and it's a very important topic. It is very frequently asked in exams. So I hope you've understood this. Thank you.